This lecture we will see parallel connection. So we have already seen cascade connection and series connection. So now we will see when the same side of the ports of two different networks are connected in parallel. So that means if we have a network N1, okay, so if we have the network N1 and N, okay, sorry, this should be N2, fine, this should be N2, and when they are connected in parallel, that means the port 1 side first terminal is connected to the port 1 side of the second network, and the second terminal of port 1 is connected to the second terminal of port 1 of network 2. Okay, this means parallel connection. Only the current divides, whereas the voltage towards port 1 of both the networks is same, which is V1. So similarly the voltage across the port 2 of both the networks is equal to V2. Yes, that you can observe, whereas the current only divides because it is parallel connection, right? Now just from the understanding of series connection, where we got the Z parameters summation for overall network Z parameters, here we will get the Y parameters summation for obtaining overall networks Y parameters. So for just proving that, we will consider Y parameters of first network and Y parameters of the second network, fine. And now what we do, we know that for the combined network, since the networks are connected in parallel, the port 1 current is the, that means the total port 1 current of overall network is the sum of the individual networks port 1 currents, that is I1 and I1 prime, fine. So here it is given the same, I1 is equal to I1 prime plus I1 double prime. Similarly we have I2 is equal to I2 prime and I2 double prime, fine. So that means in a matrix format we can write it like I1 I2 is equal to I1 prime plus I1 double prime, I2 prime plus I2 double prime. So from this equation 1 and 2, what we can write, I1 prime plus I1 double prime is equal to Y11 prime plus Y11 double prime. Similarly, this 1 2 element will be Y12 prime plus Y12 double prime, and we can get the same thing in the second row as well, and multiplied with the voltage vector V1 V2. So that means, and here if you see I1 I2 is the overall network's port 1 current and port 2 current, whereas V1 V2 are the overall networks port 1 voltage and port 2 voltage, fine. So what we can do with this, we can indicate this sum of individual two port networks of Y parameters as the overall networks Y parameters, right? So if you even simplify these matrix form equations further as a single equation, it will be more clear, right? So what we can say, the resultant Y parameter matrix for parallel connected networks is the sum of Y matrices of each individual two port networks. So this is possible because the networks are connected in parallel, and in case of series connection we have seen the resultant Z parameter matrix for series connected networks is the sum of Z matrices of each network, fine. That means whenever two networks are connected in parallel, you need to work with Y parameters, and then if you desire to get any other parameter, you can even convert one parameter to another parameter. All those concepts are there. And suppose if the networks are connected in series, you need to proceed with the series connection of means you need to proceed with Z parameters. because we can directly add individual networks Z parameters. Fine. What if networks are connected in cascade? You need to proceed with ABCD parameters, otherwise transmission line parameters. So that's it. This is for basic connections of different two-port networks. Thank you.